I mean, there's lots of sites online that present the proof from this particular perspective. There are other ways that this particular limit can be evaluated by observing. So let's say what we have is clearly, I think clearly, okay, we have that 1 plus x is definitely less than or equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus and so on. Okay? Uh, I think that's pretty clear when x is greater than 0, okay, greater than or equal to 0. Okay, when x is greater than or equal to 0, each one of these particular terms is going to be positive. Okay, and what we end up with is well, 1 plus x must be smaller than 1 plus x plus some positive uh, quantity, if that makes sense. Okay, but what this Taylor expansion is actually equal to, it's actually equal to e to the x. So therefore, what we have is that 1 plus x is less than or equal to e to the x. And that's an important identity that we have here. Now, all I've talked about is the case when x is greater than or equal to 0. We also have the case of when x is less than or equal to when x is less than 0, what actually happens here, and the proof of that actually this still holds, okay, is probably a little bit more complicated, but we won't go into it. Here now. But what we now have is we have this particular identity. I think we can sort of halfway believe that this particular identity is actually true. So let's just do a substitution. So what we know here is this, is that let's say let x equal minus x, okay? So therefore, we have from here is that 1 minus x must be less than or equal to e to the power of minus x, okay? And what does that tell us? That tells us, therefore, we have 1 minus x is less than or equal to 1 over e to the x, okay? Which effectively is telling us that e to the x is less than or equal to 1 over 1 minus x, okay? So now we have two identities. We have this identity and this identity here. Excuse me. So effectively, what we have now is we have what we effectively have here is we've bounded e to the x below and we've bounded e to the x above. So what we now have is this. So it's from, let's say this is a and b. So from a and b, we have that 1 plus x is less than or equal to e to the x, which is less than or equal to 1 over 1 minus x. Okay, and let's actually get the limit across here. Okay, so what we're going to do is we're going to calculate the limit of 1 plus x as x tends to 0 and must be less than the limit of e to the x as x tends to 0, which must be less than or equal to the limit of 1 over 1 minus x as x tends to 0. Okay. Now, clearly, the limit of 1 plus x as x tends to 0 is equal to 1. So what we now have is that 1 is less than or equal to the limit of e to the x as x tends to 0, which is less than or equal to, well, the limit of 1 over 1 minus x. Well, as x tends to the 0, this minus x is going to get very, 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 very close to 0, infinitesimally small, which is going to effectively leave us with 1 over 1, which is equal to 1. So what we now have is this, is that the limit of e to the x as x tends to 0 is greater than or equal to 1, and it's also less than or equal to 1. Okay, so therefore we must have that the limit, the sandwich term, that e to the x as x tends to 0 must be equal to excuse me, must be equal to 1, if that makes sense. Did I do the appropriate thing here? Maybe I didn't. Let me just check here. Okay, but now what we've sort of proven here is that this thing here now is tending to 1. Is that what we really required? What we actually required was that e to the h, was actually equal to e to the h minus 1 over h was actually equal to 1. So what we actually have shown is not exactly what we require. What we need is something a little bit different.